Hello again. Now it's time to answer your questions. I will start with the hardest one, number 16. Number 16 says that those are unit vectors, A, B, and C. And so unit vectors, that means each one of those has a magnitude of 1. That makes this triangle an equilateral triangle. So those three angles are 60, 60, 60. And the length of each one of those is 1. And they want us to calculate what is this equal in numbers. So I'm going to use the distributive property that we learned yesterday to expand this. So it will be A. I will dot A with everything here, A dot A plus A dot B plus A dot C plus B dot A plus B dot B plus B dot C. Okay, A dot A is the magnitude of A squared. A dot B and B dot A are the same thing because the commutative property, it doesn't matter which one we start. So this is 2A dot B plus A dot C plus B dot B is the magnitude of vector B squared plus B dot C. The magnitude of vector A squared is 1 squared because it's unit vector. The magnitude of the value of 2A dot B is 2 times the magnitude of A, which is 1, times the magnitude of B, which is another 1, times cosine the angle between A and B. The angle between A and B is the angle between the tails, not the angle between the heads. But if we extend this, A is here and B is here, the angle between the tails will also be 60. So this is cosine 60. Plus A dot C. A dot C is 1 times 1 cosine the angle between A and C, which is this angle because those are the tails, so cosine 60, plus B dot C is 1 times 1 cosine the angle between B and C. Where is this is B and C, the angle is the angle between the tails. So if we move C to here, this is vector C, remember, same magnitude with the same direction. The angle has to be the angle between the tails, so the angle here is 120. The angle between B and C is 120, not 60. Now we are done, we can start to calculate this. This is 1 plus 2 times cosine 60, which is 1/2, plus 1 times cosine 160, which is 1/2, plus 1 times cosine 160, which is negative 1/2. Oh, I forgot, there is a B, the magnitude of B squared. It should be in here. This is another one. So this, I forgot to put that. So this is plus 1 because this is 1 times 1. Okay, plus another one. Now, this is 1 plus 2 and 2 cancels out, leaves 1. This is 1/2 minus 1/2. When I multiply, 1 was 1/2 and 1 was negative 1/2 plus 1. This and this cancels out, so that will leave 1 plus 1 plus 1 equal 3. I forgot here that there is the magnitude of B squared, and I put it there. So this is the magnitude of A squared. This is 2A dot B. This is A dot C. This is B dot C, and this is the magnitude of B squared. So the result is 3 in this question. Okay. This is question 16. The only trick is to know that the angle has to be the angle between the tails, not the angle between the heads or the angle between the head and the tail. So number 11. Number 11 says, this is similar to the one I did yesterday. It says that A minus 5B and A minus B are perpendicular and perpendicular. When we know what we know about perpendicular vectors, the dot product of them has to equal 0. So I'm going to use this fact, and I'm going to do that to find. We need to find A dot B. Find A dot B. So I'm going to do the distributive property. So A dot A minus A dot B minus 5A dot B plus 5B dot B. This has to equal 0. So A dot A is the magnitude of A squared. Oh, we need to find A dot B. The magnitude of A squared minus 6A dot B. I combine those together, plus 5, the magnitude of B squared, equal 0. So this is the magnitude. Do we have the magnitude? A and B are unit vectors. That's very nice. So A and B are unit vectors. So this is 1 squared minus 6 A dot B plus 5 times 1 equals 0. So we are going to have 6 minus 6A dot B equals 0. That means negative 6A dot B equal negative 6. We divide both sides by negative 6. So A dot B will equal 1. So I will repeat again. We have these two vectors. There is two vectors A and B, and after we get the resultant of this and the resultant of A minus B, we found that we ended up with two vectors that makes 90 degree. 90 degree means the dot product of these two vectors will equal 0. We need to find A dot B, knowing that A and B are unit vectors. So the magnitude of A equals the magnitude of B equals 1. Okay, so I distribute using the distributive property. I combine those because they are alike. This is 1 squared, this is 1 squared, which is given us 5. 5 plus 1 is 6. I want A dot B, so I isolated A dot B. I send the 6 over with a negative sign. I divide it by negative 6. I got that. Now, this is the result. Now, the last question is Maya's question, number 8. Maya told me that she get the right answer, but with opposite sign, and I will explain why. It's number 8. It says that we have vector A, vector B, and this is the resultant. The angle here is 120. The magnitude of A is 7.5. The magnitude of B is 6. For the two magnitude shown in the diagram, calculate the dot product. We need A dot B. So A dot B is the magnitude of A times the magnitude of B cosine theta. Theta is the angle between the vectors, and the angle between the vectors is not the angle between the head and the tail. So I think the mistake you have done, Maya, is you consider this the angle. So 7.5 times 6 cosine the angle between them, so it is the angle between the tail. So if I move this to be here, or I move this to be here, tail to tail, I am talking about this is A, this will be the angle between the two vectors. So the supplementary angle, not this angle. If this is 120, this is 60, so this should be cosine 60. And cosine 60 is 1/2, not negative 1/2. That's why you get the opposite sign. So I think 22.5, I'm right? Yes, 22.5. Positive 22.5. Okay, I answered all your questions. I will post this on XB, and I will give you the homework for today. Tomorrow we're gonna learn another operation that's called cross product, and it is very, very important. Okay, I wish that you have a wonderful day. And